Welcome to Multiplying Polynomials. Today we're going to be working on sections from 4.3 and 4.4 of your textbook. But before we get started with multiplying, let's do a quick warm-up with adding and subtracting polynomials. So firstly, you need to add the following two trinomials: 2x squared plus 4x minus 10 plus 3x squared minus 2x minus 15. Take a moment to add those two together. Okay, so what answer did you get? First thing we need to do is group all our like terms. So 2x squared plus 3x squared will be grouped, and 4x minus 2x will be grouped, and then minus 10 minus 15. And when we combine our like terms, we end up with the answer of 5x squared plus 2x minus 25. Okay, so let's review subtracting polynomials. Here we have two trinomials, 6x squared minus 40x plus 15, and you need to subtract 2x squared plus 60x minus 10. So please take a few seconds. I'll give you 30 seconds to complete this one. Okay, so remember with subtraction, it's the same as adding the opposite. So when we're subtracting polynomials, we can apply that same principle. So we keep our first trinomial unchanged, and then the trinomial that's being subtracted, we change our subtraction sign to an addition sign, but we change that polynomial that's being subtracted into the opposite term. So all our signs have to switch. So it becomes an addition problem. So now we are adding two polynomials. And we combine our like terms and we end up with 4x squared minus 100x plus 25. Okay, so let's move on to multiplying monomials. So remember, monomial is just where there's one term not being separated by a plus or a minus sign. And if we're given two monomials and instead of adding them, we're being asked to multiply them, multiplying them is fairly straightforward. We multiply the numbers together. So in this example, 4a squared times 2a to the power of 5. The numbers or the coefficients need to be multiplied. So 4 times 2 is 8. And then the variables that have the same base, so a and a, that's the same base, we can add their powers just like we do with numbers. So 2 plus 5 is 7. So the product of 4a squared times 2a to the power of 5 is 8a to the power of 7. Okay, so what are we doing when we're multiplying monomials? You might remember when we add polynomials, we really are modeling length. So we often use the addition of polynomials to model things like perimeter. But when it comes to multiplying monomials, What we are modeling is area, because multiplication of two lengths is area. So here is an example where we are being asked to express the area of the entire rectangle below as a trinomial. So you can see at the bottom there's a rectangle with 3 parts, and they're asking us to express the area of the entire rectangle below as a trinomial. So remember, area is length times width. So if we're saying our length is negative w and our width is these 3 terms together, 5w squared minus 3w plus 4, then we are looking at a multiplication problem that looks like that. Negative w is our monomial, and then it's being multiplied by a trinomial, 5w squared minus 3w plus 4. So what we need to do is take a look at our area diagram and multiply the length and the width of each. So if we look at our little blue rectangle here, our length is negative w and our width is 5w squared. So first we need to determine the area of that little rectangle. And if we multiply the numbers together, we've got positive 5 times an invisible negative 1 is going to give me negative 5. And then our bases, our w and our w, we add their powers together, so 2 plus 1 is 3. So the area of the blue rectangle is negative w to the power of 3. Now we also need to determine the area of the pink rectangle. So that's going to be the product of negative 3w times by negative w. If I multiply those two monomials together, multiply the numbers, negative 3 times negative 1 is positive 3, and then the variables, w times w is w squared. Right, and now we need to determine the area of the little green rectangle. So we've got a positive 4 being multiplied by negative w, and in this situation, positive 4 is being multiplied by an invisible negative 1, so that gives us negative 4, and w isn't being multiplied by anything, so we keep the w. Right, so overall the area of this entire rectangle is going to be the sum of the blue, the pink, and the green rectangles. So that's going to give us an area of negative 5w to the power of 3 plus 3w to the power of 2 minus 4w. So we can express the area of that entire rectangle as minus 5w to the power of 3 plus 3w to the power of 2 minus 4w. Okay, so that's another way that we can model the multiplication of a monomial by a polynomial through an area diagram. I hope that this is kind of starting to make sense to you. Let's have a look at another example where you are just asked to multiply two monomials together. So when we're asked to multiply two monomials, like in this example, 2x to the power of 3 times by negative 3x, all we need to do is multiply our numerical factors or our coefficients, and then we multiply the variable factors or the variables. So in this particular example, our numerical coefficients are 2 and negative 3, and our variables is x to the power of 3 and x. So when we multiply, we're first going to multiply our numbers and then our variables, and that will leave us with our numbers is negative 6. Our variables, we keep the base x, and then we add the exponents 3 plus 1, and that gives us a final answer of negative 6x to the power of 4. So that is our final answer. Negative 6x to the power of 4. So that's where multiplying a monomial by another monomial without the use of an area diagram. Of course, you could create your own area diagram if you'd like, if that's easier for you to solve it that way. Okay, what if we are being asked to multiply a polynomial by a monomial? Like in this example, the number 2 that's in front of the bracket, that's a monomial, and it's being multiplied by a trinomial, 3a squared plus 8a plus 11. So we would use the distributive property, which just means the number in front of the bracket, the 2, needs to be multiplied by every term inside the bracket. So 2 needs to be multiplied by 3a squared and by 8a and by 11. So 2 times 3 is 6, and the a squared isn't being multiplied by anything, so we keep it. Then 2 times 8 is 16. A isn't being multiplied by anything, so we keep it. And then 2 times 11 is 22. So our final answer there is 6a squared plus 16a plus 22. Okay, let's have a look at another example. Let's use the distributive property to remove the brackets and simplify our polynomial. Our first example, we've got the monomial negative 4 being multiplied by a binomial 3 minus x. So firstly, we need to multiply every term inside the bracket by the term in front of the bracket, which is negative 4. So we have negative 4 is being multiplied by positive 3, and we put a plus sign, and negative 4 is being multiplied by negative x. So negative 4 times 3 is negative 12, and negative 4 times negative x is positive 4x. Or we could have written this answer the other way around, 4x minus 12. But that's our final answer there. Okay, let's look at our second example on the slide. We've got negative 4x is the monomial being multiplied by the trinomial x squared minus 3x plus 1. Take a moment, try to do that one on your own. I'm going to give you 30 seconds and then we'll go through it together. Okay, let's take a look at it. Negative 4x needs to be multiplied by every term inside the bracket. So it needs to be multiplied by x squared, by negative 3x, and by positive 1. So negative 4 is being multiplied by the invisible positive 1 coefficient, that's with the x squared, and x is being multiplied by x squared. So that would give us negative 4x to the power of 3. And then negative 4 is being multiplied by negative 3, which gives us positive 12. And x times x is x squared. And then we have negative 4 times by positive 1 gives us a negative 4, and we keep the x. So our final answer is negative 4x to the power of 3 plus 12x squared minus 4x. Is that the answer that you got? I hope so. Well done, if it is. Okay, we have one last thing that we need to know with regards to multiplying polynomials, and that is how to model it. How do we model multiplication using algebra tiles? So here we have an example where our monomial is x is being multiplied by a binomial x plus 3. So I'm sure you can already make the prediction of what the answer would be without algebra tiles. If we had to distribute that, x needs to be multiplied by everything inside the bracket. So x times x is x squared, and x times 3 is 3x. So our final answer should be x squared plus 3x. But how do we model that with algebra tiles? Well, multiplication with algebra tiles, we need to be creating an area example because multiplication is modeling area. So the way that we do this is we create a grid with a length and a width. Okay, so I'm going to put my monomial on the left here. I'm going to make that my length. I'm going to make x my length. And so I'll draw my positive x tile, lay it down lengthwise that way on my grid. And then my binomial, I'm going to make that my width, x plus 3, and I model that with my algebra tiles. I also lay them down lengthwise. So I need one positive x tile and 3 positive 1 tiles. Okay, so there I've got my multiplication statement modeled there. So now how do I illustrate the result of this multiplication? Well, I look at each algebra tile individually. Look at my first x tile on the side being multiplied by my first x tile on the top. And I'm just looking at the length of each one. The one has got an x length and the other one has an x length. Draw them out like that. It's an x times an x. And then if I fill in the spaces there, the shape that I am left with is an x squared tile. Okay, so x times x is x squared. Then I'm going to move on to my 1 tile that's on the top there, my first 1 tile. And I'm going to take its length and multiply it by the x's length on the left. So I have 1 across the top and an x length on the side. And then if I fill in the spaces there, I end up with a space that looks like a positive x tile. And if I repeat the same process for each of those 1 tiles that's laying there next to it, I end up drawing 3 positive x tiles. So what I have in the middle of my grid is 1 x squared tile and 3 positive x tiles. So I have modeled the solution to my multiplication problem, x squared plus 3x. So that is how I model multiplication using algebra tiles. Okay, so to review, we started our initial example where we were demonstrating multiplication of polynomials by using an area diagram. So if you're given a problem like this one, negative 3x is being multiplied by 2x to the power of 3 minus 4x minus 2, and you are asked to illustrate that using an area diagram. Then because it's a trinomial that's being multiplied by a monomial, draw your area rectangle with 3 parts to it, and you make your width across the top be 2x cubed minus 4x minus 2, and then your monomial can be the length on the side. And then we just multiply each of those. So 2x to the power of 3 times negative 3x is going to give me negative 6x to the power of 4. Negative 4x times negative 3x is positive 12x squared. And then negative 2 times negative 3x is positive 6x. So the overall answer there is negative 6x to the power of 4 plus 12x squared plus 6x. Okay, let's do a little check for understanding. I'm going to give you 30 seconds to work out the answer to the following. You can choose whatever method you like. Okay. Okay, what answer did you get? Did you get 6x squared minus 8x minus 2? If you did, well done. Okay, let's try one last one. 4x multiplied by 3x squared minus 4x minus 1. I'm going to give you 30 seconds once again to solve this one. Okay, did you get this answer? 12x to the power of 3 minus 16x squared minus 4x. Well done. So all that's left to do now is practice, practice, practice. Okay, so in your workbooks, you're going to turn to page 115. You're going to complete these exercises. Where you have the options to do multiple letters of the alphabet, I would like you to do A, C, and E at a minimum. If you find you struggle with a particular question, then you can definitely do more than that. You can do the B and the D and so on if you'd like to. But the A, C, E is what the minimum that's required. And remember to ask for help if you're stuck. Thank you.